7.1 Introduction to Hypothesis Testing. When we talk about hypothesis testing, what we're going to do is we're going to take a sample and then determine the confidence interval if this sample is acceptable based on what level of confidence we want, 90%, 95%, 99%. And we have to determine what level of acceptance we'll have if our sample falls within that or if we should reject it. Someone makes a claim that a hybrid car gets 50 miles to the gallon. You suspect it's not the case. If you're going to test this claim, you would sample 30 hybrid cars, so our N's 30, and you find out the sample mean of these 30 cars is 47 miles to the gallon. You get a sample standard deviation of 5.5 miles to the gallon. Now we got to determine if this advertising is false or not, based on the sample of 30 cars compared to what the original claim was. Now, our standard error, because it's a small sample, is S, which is our sample deviation, divided by square root of n number of samples. So it's 5.5 over square root of 30, which is 1.004 for all practical purposes. We're also going to assume that the advertisement is correct in this case, until we're proven otherwise. So if I graph this, I said 47 miles per hour is what I find out. They're claiming 50 miles an hour, and that's what my mean is. And I go plus and minus 3 deviations, which is 99.7%, as we recalled before. And if I go plus 1 sample deviation, that would be 51 miles per hour. 2 deviations, because we have on our sample deviation, 52. 3 deviations, 53 miles an hour. And then we go minus 1, which is 49, minus 2 deviations, 48, minus 3 is 47. Now remember, we talked about this in the last couple chapters. Anything at 0.05 or above 0.95 is considered unusual. And our sample was 47 miles an hour. So that falls at 3 deviations, which is out right at the 99.7%. So it's only 0.3 on both sides, or 0.15. So this is an unusual event, very unlikely to happen. So our sample of 30 cars says we probably shouldn't accept that it is 50 miles to the gallon. We found out with 30 cars is 47 miles to the gallon. Now, when we do a hypothesis test, we have 2 variations. We have the null hypothesis, and this is where we accept the claim that's being made. And this has the equality statement. It either has a greater than or equal to, a less than or equal to, or an equal to. And you see H of O, that is the null hypothesis. O is their name for null, is 0. So that's what the claim is representing. For example, on the previous page, the null hypothesis would have been they claim they get 50 miles a gallon for the hybrid car. So in this case, we would say H sub O within the third row equals U, or H of O equals 50 miles to the gallon. The alternate hypothesis is the complement of null hypothesis. And remember, the null hypothesis, as I said, is the equality statement, greater than or equal to, less than or equal to, or equal to. The alternate hypothesis has the inequality statement and has to go in the opposite direction. If it's greater than or equal to for the null hypothesis, then it's less than for the alternate. If it's less than or equal to the null hypothesis, it's greater than for the alternate hypothesis. If it's equal to the null hypothesis, then it's not equal to the alternate hypothesis. Again, with our previous page where we talked about, they said the car gets 50 miles to the gallon, our null hypothesis would be H sub O equals 50, or 50 mpg. Our alternate would be H sub O is not equal to 50 miles per gallon. We're going to have a lot more practice with this, but I want to get you familiar with this first. Let's look at some statements. Actually, we call these claims, and what the null and alternate hypothesis would be. A high school publicized a proportion of its students that the proportion of students involved in extracurricular activities is 61%. That anytime you have the word is or exact, that is an equal or not equal. So the null hypothesis, H sub O, is P equals 0.61, which means the alternate is is not equal to 0.61. And again, remember the null has the equality statement. A car dealership announced that the mean time for oil change is less than 15 minutes. Now we have to be careful here. This is less than, and it's not less than or equal to, it's less than. So that means it's not an equality statement, it's an inequality. That means they're making the claim on the alternate hypothesis. H of A, the alternate, is less than 15, which means the null has to be going the other direction and equality. So if my claim at the alternate is less than 15, then my null is greater than or equal to 15. Notice each sign goes in the opposite direction, and the null always has the equality statement. A company advertised that the mean life of its furnaces is more than 18 years. So this is more than, not an equality statement. So the claim is on the alternate hypothesis. U is greater than 18. Which means the null has to be the equality statement, has to go in the other direction, which means U is less than or equal to 18. A consumer analyst reports that the mean life of a certain type of automobile is not 74 months. That's an inequality, not equal to. And that's where the claim they're making is. Again, the claim can be in the null or alternate. So the H sub A, the alternate, is U is not equal to 74, which means the null has to be the equality statement, which means it is 74. U equals 74. An electronic manufacturer publicizes that the variance of life of its home theater systems is less than or equal to 2.7. There's the equality statement. It's less than or equal to. So that would be on the null hypothesis since it's the equality statement. And variance, remember, is deviation squared. So the variance squared, deviation squared of the variance, is less or equal to 2.7. That's the claim we're making, which means the alternate has to be the inequality, which is greater than or equal to 2.7. A realtor publicized that the proportion of owners who feel their home is too small for their family is more than 24%. That is an inequality. It's more than. That means it's on the alternate hypothesis. The claim is on the alternate. P is greater than 0.24, which means the null has to be the equality going the other direction. P is less than or equal to 0.24. And when we perform the hypothesis test, we can either reject the null hypothesis or fail to reject the null hypothesis. And we don't use the word accept. We use fail to reject because we'll never have 100% proof. It's just like in court, and we'll talk about this in a moment here. They never say guilty or innocent, they say guilty or not guilty. So we either reject the null hypothesis, the H of O, or we fail to reject the null hypothesis. We never look at the alternate in terms of what we reject or fail to reject. It's always the null hypothesis. Suppose you flip a coin 100 times, you expect it to be 50 times heads, 50 times tails. However, you get 21 heads and 79 tails, and you suspect the coin is not fair. Well, we're going to make the null hypothesis, there's a statement of equality, that should be 0.5, which means the alternate hypothesis would be it's not equal to 0.5. Now, we're going to talk about quality towards the end of the semester here. But when we talk about quality, we have type 1 and type 2 errors. On the left here in the decision is we reject H sub O or do not reject H sub O, our null hypothesis. This is the decision we make. And then on top here, the truth is what is the absolute certainty? If we know the null hypothesis is true and we do not reject it, in other words, we accept it, but we do not reject it, that's the correct decision. If we know the null hypothesis is false and we reject the null hypothesis in the lower right corner, it's always the correct decision. What if the null hypothesis is true and we reject it? That's a type 1 error. An example of that could be that we found out let's say some kind of food at a manufacturing plant is contaminated. If we reject the null hypothesis, that's not contaminated, but it's true, people are going to get sick. On the flip side, what if we do not reject the null hypothesis and the hypothesis is false? In that case, we're going to lose money. We're not rejecting it, but there. And as I said before, our court system in the United States is the same way. You can be innocent or guilty. That is, the court will never know. It's what the facts prove and how the jury decides or the judge decides. But if you're not guilty and you truly are innocent, then justice isn't served. If you are guilty and they find you guilty, then again, justice isn't served. Where the problem comes in is if they find you not guilty and you commit the crime, well, now you got away with something. Or on the flip side, what if they find you guilty and you're actually innocent? That's type 1 error. Type 2 is you get let go because you're truly guilty, but they find you not guilty. Now, here's an example. The USDA limit for salmonella contamination, with chicken, for ground beef is 7.5%. The meat inspector reports that the ground beef produced by the company exceeds the USDA limit, which is 7.5%. You perform a hypothesis test to determine whether the meat inspector's claims are true. Will a type 1 or type 2 error occur, which is more serious? Let's see here. If it's the null hypothesis is less than 7.5%, where the p is less than 7.85 or equal to, we claim, but the alternate point is greater than. If we reject the null hypothesis, we're going to lose money that way. We're going to throw out meat that's perfectly fine. This is type 2 error, and they're going to lose money. Type 1 error is the more dangerous one. The claim is that's greater than points. Alternate is 0.75, and the null hypothesis is less than 7.5, and we don't reject it where the actually was greater than. Now people could get poisoned. Company specialized in parachute assembly states that its main parachute failure rate is not more than 1%. By the way, if it's not more than, that's going to be less than or equal to. It can be 1% or less than that. For a hypothesis test, determine whether the company's claim is false. Was it type 1 or type 2? Which is more serious? Well, let's see here. The claim is it's less than or equal to 0.01, so that's the null hypothesis. The alternate is it's greater than 0.01. So it's a type 2 error if we do not reject it, and it is greater than 0.01. Type 2 error, we don't reject it, and what happens? The parachute doesn't open. On the flip side, if the null hypothesis is greater than or equal to 0.01, and we don't reject it, where it actually is greater, and the alternate is greater than 0.01, well, then the company could have some problems because they're saying it'll fail when it really hasn't been. Now, I'll be working through all these, but I want to show you right now, if we're talking about U, the population parameter, and we use a sample, population parameter is U, that's the mu, the X bar is the sample average, and we use the Z-score or the T-distribution, depending on, remember, if we have a sample deviation or not. If we're looking at proportions, population proportions, P, the sample proportions, P hat, again, we use the Z table. We've done this before. And the variance for the population, we use the sample variance, and then the standardized test statistic is the chi-squared. Well, we will not be doing that in this class, but I wanted to make aware of it. I should say the three most common levels of significance, and I've talked to you about this before is 0.01, alpha 0.05, and alpha equals 0.10. And what this means is, in the last chapter, we were talking about 90% down the middle, 45% each side. This is the flip side of that. If we have 90% confidence, that means there's 10% remaining each side, 0.1. If it's 95% confidence interval, that's 0.05 remaining, which is 0.025 on each side. And if we have alpha 0.01, that's 99% confidence, 0.005 on each side, which adds up to 0.01. We're looking at what's left over from that confidence interval in each tail. We could have a left tail test, and this is if it's greater than, and these are on the alternate. Remember, the null always has the equality statement, less than or equal to, greater than or equal to, or equal to. If it's a left tail test, as we see in the middle here, and the alternate would be where the tail is on the left side, where the alternate is more likely, and that's be less than. If the alternate is greater than, then that's going to be a right tail. And if it's two-tailed, that is where it's not equal. We're looking down the middle, and it is on each side of the tail, we would reject it. Now, we were talking about these before, and I'm going to map this out for you here. Consumer Analyst reports that the mean life of a certain type of automobile is not 74 months. Remember, the equality statement is the null hypothesis. And they're saying it's not 74 months. So the claim is on the alternate hypothesis. U is not equal to 74, which means the null hypothesis, U equals 74. And if it's equal or not equal, that's two-tailed, which means what we accept or fail to reject is the blue part in the middle. Those white parts on each side are the rejection range. Manufacturer publishes the variance of theater systems is less than or equal to 2.7. So the equality statement, and this is going to be one tail, is less than or equal to 2.7, which means the alternate's greater than 2.7. And the easiest way to look at this is if you look at which way the alternate is pointing here, right here, it's pointing in that direction. So guess where the tail is? It's on the right side, same side it's pointing on. A realtor publicizes the proportion of homeowners who feel their house is too small for them is more than 24%. So that's the alternate hypothesis. That's what the claim is. It's more than 24%, greater than 24%. Which means the null has to be less than or equal to, because that's where the equality statement is. And again, the alternate, where's the arrow pointing? It's pointing that direction. And where's my tail? It's on the right side, same direction as it's pointing. Now, as we talked before, we have claims and we may have a decision. The claim can be on the null or alternate. Again, the claim can be on either side. The important thing to understand is the null hypothesis has to have the equality statement. If you make a claim as less than, well, then the null hypothesis has to be greater than or equal to. If you make a claim that's greater than, then the null hypothesis has to be less than or equal to. If you make a claim that it's greater than or equal to, then the alternate has to be less than. Let's look at this. These are from the beginning. A school publicizes that the proportion of students who are involved in at least one extracurricular activity is 61%, which means then it's equal to my null hypothesis H. Null hypothesis H of O is P equals 0.61. So the alternate P is not 0.61. If you reject H sub O, if you reject the null hypothesis, you're concluding there's enough evidence to support the school's claim that the proportion of students who are involved is 61%. If we fail to reject it, then we are concluding there's not enough evidence to reject it. A car dealership announced that the mean time for an oil change is less than 15 minutes. Again, so that's going to be alternate because it's less than. Because the null is greater than or equal to. If we reject the null hypothesis greater than or equal to, we're kind of concluding that there's enough evidence to support the Carlier's claim that the mean time for an oil change is less than 50 minutes. So if we reject the null hypothesis that's greater than or equal to, then we're supporting the claim. If we fail to reject it, we're saying it is greater than or equal to, we can't support that claim. Consumer analyst reports that the mean life of a certain type of automobile is not 74 months. So this is equal and not equal. And remember, the claim is on the not equal in this case. So it means the null hypothesis has to be the equality statement. It equals 74 months, and the alternate is not equal to 74 months, what the claim is. If we reject the null hypothesis, we're accepting the claim sitting on the alternate. That's not 74 months. If we fail to reject H sub O, in other words, we accept it, but we fail to reject it, then we're going to say the mean life of battery is 74 months. A realtor publicized proportion of homeowners who feel their house is too small for them is more than 24%. That's on the alternate because it's greater than, more than 0.24, which means the null hypothesis, the equality statement, is less than 0.24. If we reject the null hypothesis, then we're saying we conclude there's less than 24% of homeowners feel their home is too small for them. If we fail to reject it, then we're supporting the realtor's claim there's at least 24% out there. Here's the order how we do things. We'll be doing this in class as well. State claim mathematically. Remember, you got to identify the null and alternate. The null is the equality statement. The alternate is the inequality statement. The claim can mean either one. What's your level of significance? And if it's a 90% confidence interval, then it'd be 0.10. 95 would be 0.05. Then what I always do, and you'll see this on our work, determine a standardized sampling distribution and sketch the graph. It's easier to see how many deviations it is and where the mean is, and you can put some numbers to it. We calculate the test statistic and the standardized test statistic. And then we find the p-value. P-value is less than or equal to the level of significance. We reject the null hypothesis. P-value is less than or equal to the level of significance, left-tailed. We also reject it. If it's greater than or less than level of significance for two-tailed, we reject it. But if it falls within those, we would fail to reject it. It means, I can't say accept, but basically we accept the null hypothesis. Now, one thing, for ethical reasons, you cannot use a hypothesis test to support your claim if your claim is the null hypothesis. And that's if you're making a claim. You need to support your claim by wording it so it's the alternate hypothesis. Let me give you an example here. A medical research team is investigating benefits of a new surgical treatment. One of the claims that they're making, this is the team doing the research, that the mean recovery time for patients after a new treatment is less than 96 hours. So if they're writing it for ethical reasons, they cannot make the claim on the null hypothesis that's less than 96 hours, less than or equal to. They have to do it on the alternate. They're going to make the claim that it is less than 96 hours, but that's got to be the alternate. They got to try to prove it's greater than or equal to 96 hours, so it's the counter. Now, if you were a competitor, you could say, we're going to see if it's less than or equal to 96 hours, and put the claim on that. And then the alternate would be greater than. But you cannot try to make the claim on your own as the null hypothesis. Let's look at two more examples here for setting up these claims and interpreting them. You represent a chemical company that's being sued for paint damage to automobiles. You want to support the claim that the mean repair cost per automobile is less than $650. I see the word less than, I know it's going to be the alternate hypothesis. So the equality statement has to be in the null, which is going to be greater than or equal to, opposite direction. How do you write the null hypothesis? How do you interpret the decision that rejects the null hypothesis? So H sub O over null hypothesis has the equality statement, U is greater than or equal to 650. You're taking the claim as less than 650 because that if it's less than, that's always going to be the alternate. So the statement of equivalence is greater than or equal to 650. And as I said, if you're doing the research yourself, ethically, you have to take the alternate hypothesis. If you reject the null hypothesis, you reject it's greater than or equal to 650, then your standing repair cost is less than 650. If you fail to reject it, you're saying your claim isn't true and it does cost more than 650. You're on a research team that's investigating the mean temperature of adult humans. A commonly accepted claim is that the mean temperature is 98.6. So I see is 98.6. That's going to be the claim of that statement of equivalence. That's an equal. So that's going to be my null hypothesis. H of O equals 98.6. You want to show the claim is false. So you're trying to prove it's false. So you have to take the alternate. How do you write the null alternate hypothesis? Well, I said they're making the statement of equivalence. It is 98.6. The word is means equal to, which means the alternate has to be not equal to, and that's what the alternate AU is not equal to 98.6. If you fail to reject the null hypothesis, you accept it, then you're saying temperature is 98.6 degrees Fahrenheit. If you reject the null hypothesis, then you're saying the mean human temperature is not 98.6. It's the entire lore, it's just not 98.6. So the statement of equivalence is the claim. So you have to accept the alternate hypothesis.